we're in chapter 5, section 2, which is on sinking funds. The big idea with sinking funds is that we have regular payments made, and then at the time of the last deposit, we are trying to accumulate that amount. So that's all sinking funds are. So this is an S sub n problem, which is why it's called S sub n, because we're sinking the funds to create it. Okay, so again we have n regular payments. Okay, and then we'll have our interest rate. So just as a refresher, S sub n is equal to r times 1 plus I to the n minus 1 all over I. And then if we wanted to find r by itself, but we know how much we want to sink, we would just divide by this on both sides. So we get r equals S sub n times I over 1 plus I to the n minus 1. So again, these are both from section 3.1, just like an amortization, real similar process. So the idea here again is that we want to figure out how much that is. So a lot of times, just like when we are looking at amortization, what ends up happening here is a lot of times whoever is sinking the funds in will round up the payments. So we still may have that difference between the last payment or the concluding payment because we have the round up. So again, just those leftover formulas. So leftovers after the nth payment would be, in this case, I'm just going to call it S sub n. So it's whatever you're trying to accumulate. Okay, so I'm going to call that S sub n minus, and then it's going to be minus the payments you've put in so far. Okay, but again, this is not going to gain interest because it's at the end of the timeline, because the whole idea of getting leftovers is we're moving everything forward to that moment. So that's why we have the two distinctions here. And then if we want to figure out, say how much would be left over for the next payment, so if we make so many full payments and then we want to finish that last payment one period later, we would again not move this at all because it's already there at the end of the timeline. We just move it over here this way. So this one becomes SN due. But this again wouldn't stay the same. We did a few examples like this in section 4.1. I think we touched on it in 4.1, that they just weren't as popular. Because sinking funds, they aren't not as popular because usually they end up being not as good. But it's not always the case because it really depends on what you're trying to do and the purpose of what you're doing in terms of your assets, and maybe if you have cash flows, because sinking funds are used more with businesses than with home loans. So let's do an example. So a couple wants to have $30,000 at the end of 4 years to make a down payment on a house. How much should be deposited at the end of every quarter? So again, we have the end, so we know that we're looking at that. So that the couple has the money, and our interest rate is 4.5%. So we have our timeline here. Okay, end of 4 years, so this is our 4-year mark. We want $30,000. And then we make a down payment, and then end of each quarter, so that means we're not going to make a payment now. 0 now. First payment's in 3 months. Okay, so we're going to make this many payments because we're going to make it at the same time to get that $30,000. So we're going to have 4 payments a year because we're quarterly times 4 years, so 16 payments. So that means that S16 is that 30,000. And then our R here is 0.045, and that's quarterly. So that I is going to be 0.045 over 4. So now we're just going to use our formulas from up here. So I'm just going to go straight to the R formula because again it's just a little quicker. You can do either way. You could totally do the coefficient method if you wanted to. Okay, so again, this is S sub n, so our denominator is going to be the 1 plus to the positive, and then minus 1 because we're moving everything down. So that looks on the calculator. So in your denominator, that's where you're going to have your double set of parentheses to start. So that means that our regular payment at the end of each quarter is going to be $1,721.80.8. So again, we're going to round up because it's a payment. So even if this was a 4, I'd still round this up. Okay, so that means that that 16th payment would be just slightly less because we rounded up. Rounded up.